Hi everyone, welcome to another video. In this video, we are going to talk on problem number 1572 that talks about summing the diagonal values in a square matrix. So, just to read the question, given a square matrix mat, return the sum of the matrix diagonals. Very straightforward. And we have to only include the sum of all the elements of the primary diagonal, which is this one, and all the elements on the secondary diagonal, which is this one, that are not part of the primary diagonal. Basically, it's saying that for example, for this example, 5 should not be taken twice into the sum calculation, basically. And this is a very crude example. There are two more examples which you can see if you just pause the video. So, just to save our time, I have just done a brute force approach, and uh, as you can see, I submitted it. It went fine, but obviously, we should not be using nested loops. And just to describe what I've done is that basically, obviously, we need to initialize a sum variable in which we'll be storing our sum, and at the end, we are returning that sum. I've taken two more variables, which is min and max. Min is basically the first element of the arrays inside that matrix, and the max is the last element of that array. Now I'm using two loops. The outer loop will traverse through each row of the matrix, and the inner loop will traverse through the respective array, uh, which is inside that matrix row. Now, in the inner loop, I've placed one condition that if I equals j, that means, for example, if you consider this one, sorry, I can't really show in a user intuitive setting, so I'll just use a mouse cursor to demonstrate in the best way possible. So if you consider this one, this is at 0, 0. Okay. If you consider this 5, this is at 1, 1. If you consider this 9, this is at 2, 2. So these are the positions where we find that the index of what do you call it, the matrix, that is a row, and the column, that is the array element, are equal. So that one condition we need to pick. Or if you see that uh, this one 3, so it is 0, 2, right? If you consider 9, then it is no, sorry, not 9. If you consider as 7, then it is 2, 0, right? Sorry, 2, 0, yeah, 2, 0. So their sum should be equal to the max. Max is basically what? In this case, it is 3 minus 1, that is 2. So 3, that is 0, 2. That means 0 plus 2 is equals to 2. For 7 also, it is 2. So in that way, we are having two conditions, and we are just summing up those values and returning it. So I've run it, and it got accepted, but obviously the runtime and the memory is pathetic, as you can see. And we just need to avoid inner loops or nested loops, so to say. So let's look at a more refined solution or a better approach to solve this problem. So yeah, let's see. So before we dive into the coding part straight away, let's analyze the simple logic behind this refined approach. First of all, I have just downloaded this page as a PDF as I wanted to annotate that whole approach using my mouse. Please bear with me. I don't have an iPad or an Apple Pencil to annotate this. For now, just bear with me. Now, first of all, we need to pick the diagonals. Okay. So, in matrix questions, what I have noticed is that you just have to play with the indices or the indices, whatever you want to call it, indices of the elements of the array. Okay. So, let's do that only. So, first of all, pick those indices or just uh, notice the pattern of the indices for every row and column. Okay, so for 1, the coordinates are 0, 0. For 3, the coordinates are 0, 2. For 4, the coordinates is 1, 0. For 6, the coordinate is 1, 2. For 7, the coordinates are 2, 0. For 9, it is 2, 2. Okay, I've done nothing now up till now. I've just picked the first and the last element of the every row. If you notice, the row is increasing by 1, obviously 0, 1, 2. The column remains the same. Here, the column changes, row remains the same. So now it's our turn to observe a pattern among the indices of this matrix so as to avoid the brute force approach, and we need to pick one row and extract the sum out of that row in every iteration. For example, in this particular row, we need to pick 1 and 3, which is the sum of which is 4. We need to come out of that iteration with 4. Then we pick 5, then we pick 7 and 9, like that, so on and so forth. So what kind of a pattern can we observe here? And obviously, we need to pick those elements which are involved in the diagonal. That means for this, we need to pick 1 and 3. For this, 5, 7, and 9, like that. So if you observe carefully, there is a pattern. So if I need to pick 1, it's just basically 0, 0. That means I. Okay. If I need to pick 0, 2, that is I. And then 3, that is N. You can say max, basically the length, max. Sorry for the overwriting, yeah. Max minus I and then minus 1. So yeah, this is the pattern that we are observing. Why? Because if you notice 1 and sorry, not 1 and 2. If you need to pick 5, okay, how will you do it? Or let's say if you need to pick 7, what do we need to do? We need to say sum basically will be the sum of these two values, right? So what we'll do, I, that means 2, 2, right? Because here the I will be 2. So 2, 2, that means 9, plus I, that means, let's just say 9, I, that means 2, and then max, that is 3, minus 2, minus 1. If you see that, it is 9 plus basically 2 and 0. So this is 7, which gives us 16, correct? So to start off, we'll just get rid of this inner loop. We don't need that anymore. We'll just get rid of these two extra variables as well, min and max. And straightforward, we'll just say sum would be sum plus initially it's 0 and our logic, right? So it should be mat of I and I, because one of the numbers in the matrix composing the diagonals would be that number whose indices are the same. So for example, the numbers like 1 and 5 and 9 are those kind of numbers where the indices are the same. So that so this particular mat of I and I will pick those numbers, right? And then we'll say mat of we have I, obviously, and then we have to say mat dot length minus I minus 1. Mat dot length is basically our length of the matrix. Uh, and then, yeah, it should be done. I think I'm missing something. Also, yeah. Here the question says that the main part. We have to exclude that element which is occurring on both the diagonals. Since it is a square matrix, obviously that might happen, right? So that will happen only when the number of or the length of the square matrix is odd, right? So if we'll just say mat dot length mod 2 not equal to 0, then we'll say we'll just subtract that number. That will be a better approach to this problem, right? So it will just say sum equal to sum minus that particular element. Okay. Now, what would be that element? It should be the central uh, element, right? So in this case, if you see 5, the position for 5 is 1, 1, and 1, 1, yeah, 1, 1. So how would we obtain that? Basically, it's a central element. So mat dot length by 2, yeah, also the same. So yeah, it should work now. Here actually, mat dot
Okay.
length by 2 will
And
give us
stop
the 1,
stop the meeting.
in the sense that if the length is 3, then 3 divided by 2 will
The
give us 1.
runtime is excellent.
So yeah.
Wow.
So yeah, that was my learning and a small and a silly demonstration. I hope you like it and it was of some help. So yeah, always a learner. Thank you. Bye bye.